Hi everyone, this is Mr. Gallagher, and for today's Algebra 2 lesson, we'll be working with absolute value functions. Well, first, when we're talking about absolute value, that's symbolized by these two bars here that are around x, what we're really saying is for the number that's inside the absolute value bars, how far is that number from 0? So if I have a number like 3, well, the absolute value of 3 is 3, because 3 is 3 units away from 0 on a number line. If I have a number like negative 3, when you take the absolute value of it, you also get positive 3. That's because negative 3 is 3 units away from 0, but on the other side of 0. So we have two equations here. Y equals the absolute value of x, and f of x equals the absolute value of x. They basically are both the same thing. And here to the right, we have the picture. This picture is what it looks like when we graph this absolute value equation. F of x equals the absolute value of x. One thing that's important to remember, absolute value functions will always have a V shape to them. Sometimes they'll be in a different position or a slightly different shape, but for all of the absolute value functions that we work with in Algebra 2, we can expect a V formation to happen somewhere on the coordinate plane. So our directions for this example, graph the following absolute value function and then identify the domain and range. We have h of x equals the absolute value of x minus 2. We're going to begin this problem by making a table of values where we supply the input values x, we'll put them into our function rule, and then we'll get output values of y. We'll then put those x's and y's together to form ordered pairs, and we'll plot the ordered pairs on our graph. When we're all finished, we'll have a picture that represents our function. Well, when I think about what values I like to use for my inputs, generally I want to keep things as easy as possible, especially in the beginning. So I'm going to choose the 5 easiest input values that I can think of. I'll choose 0, 1, -1, 2, and -2. I'll then replace x with each of those 5 values in my function. And then one at a time, I'm going to simplify each of those to get my output values, or y. So 0 minus 2 is -2. The absolute value of -2 is 2. 1 minus 2 is -1. The absolute value of -1 is 1. -1 minus 2 is -3. The absolute value of -3 is positive 3. 2 minus 2 is 0. The absolute value of 0 is 0. And -2 minus 2 is -4. The absolute value of -4, positive 4. I'll take each of those pairs of x's and y's and I'll put them together then to form my ordered pairs. And these will be the 5 points that I plot on my coordinate plane. So the first one, 0, 2. We'll put a dot at 0, 2. My next one, 1, 1. -1, 3. 2, 0. And -2, 4. So I've plotted all 5 of my points, and as I said before, we're really expecting to see a V shape here, and so far I don't really see that. All I see are 5 points in a straight line. So it doesn't mean that we made a mistake or anything like that. All it means is that we probably haven't put enough points in yet. So I'll choose what I feel is the next easiest number to work with. I'll put 3 in for x. When I put 3 in for x, it'll get me 1 as an output value, so 3, 1. And there you can see that our line begins to bend at that point. So really, I think maybe one more point just to make sure. I'll put 4 in as an input value. That's going to get me 4, 2. I'll plot that point. And sure enough, now I can really see the V pattern that's forming. So I'm pretty confident I'm able to stop plotting points at this point, and I can kind of just connect the dots with my lines. So that's the picture of the function h of x equals the absolute value of x minus 2. The only thing left for us now is to identify domain and range. For my domain, I'm asking how far does my graph go to the left and to the right, and it appears it It's going to go on forever to the left. It's going to go on forever to the right. There are no gaps in the middle. So my domain is all real numbers. For my range, I'm asking how far up and down does my graph go? Well, these arrows once again will continue on forever, so they will continue going up. It's going to go up forever, but it will not go down forever. In fact, I can see the lowest possible value on the y-axis that I will ever reach, and that would be at 0. I'll never get to a y level that's lower than 0. I can be equal to 0 when x is 2, my y value is 0, but I will never have a y value that's lower than 0. So I need to come up with a statement for the range that will tell me that I can be as low as 0 and I can go up to any possible number above it, but I will never be below that. The way we say that, all y such that y is greater than or equal to 0.